Hey everybody, this is Mr. Bellis here, and I just wanted to let you know that we're starting on Chapter 8, and it's on something called sequences and series. And it basically looks in patterns of numbers. So like if I had a 2, a 4, a 6, and an 8, I said, hey, what's the next number? You, of course, would say 10. That'd be a pretty easy one. Sometimes the patterns are a little bit more difficult. So maybe I did a 1, a 4, a 9, a 16, and I said, what would be next? And you would go, maybe it's 25, and you realize all those numbers are squared. And it's looking at how we can find out those patterns that are added or multiplied to get, and then being able to sum up some of those sequences of numbers, so that if I knew that I made, say, $12,000 this year and I expected $500 increases per year for the next 20 years, is there a formula that I can write to tell me how much money I would earn over the course of this job? That's what we're getting to. So here we go. Hopefully this will work great for you. This is Sequences and Series, section 8-1. And again, this section, pretty straightforward. So the first one, it says, what is another name for summation notation? So, well, first off, what the heck is summation notation? There's this little thing. It's a Greek letter. The Greek letter is called a sigma, S-I-G-M-A. And this tells us that we want to sum things or add things up. And it'll tell us right at the bottom of this thing where we want to start with the first term and how many terms we want to go to. So we want to go from the first term to the fifth term. And we'll put something like this, 2n plus 3. And basically that means that this thing right here generates our sequence by plugging the numbers in. So 1, I plug 1 into here, 2 times 1 is 2, plus 3 is 5, that's the first one. Since we're summing, it's going to create the next one, so I plug in the next number, which is 2, 2 times 2 is 4, plus 3 is 7. And then the next number would be 3, 2 times 3 is 6, plus 3 is 9. The next number would be 4, 2 times 4 is 8, plus 3 is 11. And then I put in the next number 5, 2 times 5 is 10, plus 3 is 13. Put in the next number and wait, nope, see that? That's our stopping point. So once we get to the fifth number, then we stop. And then we simply add these things up. So 5 and 7 is 12, and 9 is 21, and 11 is 32, and that's 45. So the sum of this sequence is that. But what's another name for it? Right there, sigma notation. So complete this sentence. In a sequence, the numbers are called blanks of the sequence. Well, the numbers are actually called terms of the sequence, so whichever term it is. So when I get to number 5 right here, it says write the first 6 terms of this sequence. Well, this is what we call an explicit sequence, and it tells you what it is. So literally all you have to do is plug it in. So if you want to know what the first term is, you plug in a 1. So 1 plus 2 is 3. You want to know what the second term is, you plug in a 2. 2 plus 2 is 4, and so on down the line. So you can finish off the rest of those. Same thing here, write the first 6 terms of this sequence, 6 minus n, and that would tell you what those are. So the sequence can go up and get bigger, or go down and get smaller, and they can go through addition or subtraction. They can also go through multiplication or division. It won't really matter which ones they are. Sorry, this was that bottom one right there, 6 minus n. So I'll go ahead and put the first term in there. So plug in a 1. 6 minus 1 is 5. So this would be 5. And then 6 minus 2 would be 4, and so on down the line. Okay? So pretty easy on the first couple right here. Write the first 6 terms, write the first 6 terms. Those ones are pretty straightforward, so you can do that. Exercise 29, they don't give you a formula. They're like, oh crud, don't have a formula. So what you have to do is you have to look at the picture, and you go in the first one, it says write a rule for the number of people that can be seated around n tables. So one table right here, looks like there's 1, 2, 3, 4, 5, 6 seats. When I put 2 tables together, it looks like I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 seats. When I put 3 tables together, I got 6 on this side, 6 on that side, that's 12. The end cap's 13 and 14. I got that. Look at that. And hopefully you can see that each time I add a table, I'm just adding 4 to it. So this next one would be 18. And the 5th one would be 22. And that's great, and I've got my thing, but I want a rule for it. So how do I get this? Well, I look and I see that it's going up by 4, and it's going up by 4, and it's going up by 4 each time. So that must be 4 each time, 4n. Good deal. So now I know that when I plug a 1 into here, 1 times 4 is 4, but I'm supposed to get a 6. So what would I have to add to this? I'm going to call this my fixer. What would I have to add to this to fix it so that I get a 6? And hopefully you got that now, and you can fill that in and plug that into the box. Okay. So I move on to here, and this was just a chart that if you wanted to use that, 1 table was 6, and 2 tables was 10, and 3 tables was 14, and 4 tables was 18. And you're like, wait, man, this looks like basic algebra stuff, right? Because then this gets me a what? This gets me a line, doesn't it? So an arithmetic sequence, something that goes up by addition, gives me a line. And now you can see the slope right here. The rise is 4, and the run is 1. So 4 over 1 is 4. That's the same slope that I got in my equation. And the y-intercept is exactly what you just put in the last one. So hopefully you wrote 4n plus 2. That's the sequence that generates those terms. Now, why is this different than just drawing a line? Because technically the red dots are the only things that make sense on this. The red dots. Well, why is that? Because if I was to put a red dot right here where this black X is, that means that I have 2.25-ish tables, and I get a little over, like, I don't know, 10.5 people. Oh, that doesn't make sense. You can't have partial tables, or you can't have partial peoples. So the red dots really are the terms of the sequence, and all the spaces or gaps in between this don't really exist. Okay? So this one says an employee at a construction company earns $33,000 for the first year of employment, and then receives raises of $2,400 each year. Write a rule for the salary of the employee each year. Let's see, year 1 was $33,000. Year 2 was $33,000 plus $2,400, which is $35,400, like that. Year 3 is $33,000 plus $2,400 plus $2,400. You can see how this is going up, and then you get $37,800. So you just need to know that the rule is, right, 2,400n plus, and I'm going to give you a little thing, this little fixer thing, this is always nice with arithmetic, repeat with arithmetic. This fixer thing is simply whatever this one number would be. So if this is 3, this is 2, this is 1, whatever the 0th term, a sub 0, would be, that's what your fixer is. Okay? So the term before the 33,000. Figure out what that is, 2,400 down from that, put that number into there, and that's your rule. Okay, so there's some things here on summation notation. So I'm going to leave this one for you because that one's pretty, I think it's pretty easy if I do the next one for you. So I'm going to do this one right here and see if you guys follow along with this. So summation notation. 1, 2, 3, 4 plus dot, dot, dot. Holy crap, what does that mean? Dot, dot, dot means that it continues the pattern forever. So my summation notation has to go from n equals 1 all the way to, yep, crazy as it may seem, all the way to infinity, because it never stops. Now the question is, how do I get this? How do I get 3, then 9, then 27, then 81? Well, 3, 9, 27, 81. That looks like 3 to the first, and 3 squared, and 3 cubed, and 3 to the fourth. Does that make sense that that generates that pattern? So I simply need to do 1 over 3 to the nth. Okay? I believe that you can probably do it for the pattern for this one right here, but that was number 35. Looks just like that. And hopefully that works out well for you. And the rest of these ones are pretty basic stuff. Simply ask you to find the sums. So I'm going to go ahead and do one down here at the bottom again, and because this one maybe there's more stuff to it. But finding the sum for this one right here, it says n equals 1 to 5, so it needs, if I need 5 terms, 1, 2, 3, 4, 5 terms. And I need to find out the value. So when I plug 1 in here, 1 squared is 1 minus 1 is 0. 2 squared is 4 minus 1, which is 3. 3 squared is 9 minus 1, which is 8. 4 squared is 16 minus 1, which is 15. And 5 squared is 25 minus 1, which is 24. Nope, see it again? That stops it at the 5th term, so I don't need to go any higher than the 5th term. Okay? So then I need to add those. So the sum of this, 24 and 15 is 39, and 8 is 47, and 3 is 50. So the sum of those terms is 50, and I'm pretty sure that you could do that for the rest of these ones right here on this chart, which takes us all the way to this final question right here. It says, you begin an exercise program. The first week you do 25 push-ups. Each week you do 10 more push-ups than the previous week. How many push-ups will you do in the 9th week? So you got 25, then you got 35, then you got 45. And what you need to do is you need to find a pattern for this, and we want to find out what's in the 9th week. Now, here's the dealio with these patterns. You obviously could just go, okay, first week, second week, third week, 4th, 5th, 6th, 7th, 8th, 9th, and just keep adding those numbers up. And do it. Absolutely do it. Now, if I ask you, what about the 519th term? I don't think you want to write all 519 of those terms out. So our hope is that you can find a pattern which allows you to write a rule for that sequence. And if you can do that, it makes it a lot shorter. So on this one, your choice. We're going to get into writing rules later on in the section. So your choice. You can just do it out until you get to the 9th one and find out how much it is. Or you can go, no, Mr. Bellis, I can write a rule. I believe that I know what this pattern looks like. And I can write that a sub n equals, and whatever that pattern is to get that term. Okay? And as we work through this stuff, we're actually going to find out, if I said, well, how many push-ups were there in the 519th week? You could find that number, and that's pretty cool. But there's also formulas that can tell you how many push-ups you've done over those 519 weeks, which means that we can sum all of those things up too. Good deal. Awesome. Hope this was really beneficial to you. Stay on top of the stuff. Good job. We'll talk to you later.